Okay, so we've got a graph. Imagine, because there's not really a good explanation here. So we've got 3 bags. We've got bag A, we've got bag B, and we've got bag C. And the 3 bags have all been placed into the same solution. So this is our solution. We don't know what's in the solution. The question is, based on the results, which one of those bags, A, B, or C, was hypertonic to the solution at the beginning?
Yes.
A.
He says A. Agree?
Yeah.
You think A also?
Yeah.
I don't know what this is.
I don't know what that is either. I was trying to decide if that was supposed to be some kind of perverted gesture. All right, A is correct.
Yes.
Here's why. Remember, water always goes towards a hypertonic solution. So whichever bag was hypertonic, it would gain weight. So what does that tell you about bag B?
It was hypertonic.
Bag B must have been isotonic.
I was still looking at it. That was hypo.
And bag C must have been hypotonic. Now here's a question. Is it possible that the solution in my beaker is water?
C.
No, it's green.
Okay, and regardless that I colored it yellow, is it possible that it's water?
It might have some water in it.
It's probably water.
No, it is not possible.
It's not why.
Depends. We don't know what's in the bag. So never mind.
Yeah, it had to be water.
It's lemonade.
Let me ask you, think about this for a second. Is there any bag that I could put into pure water that the bag should lose weight? Can water be hypertonic to anything?
No.
No. If this was pure water, there's no way a bag would have lost weight. I mean, unless it had a leak or something. Right? Because it has no solute in it. It can have negative amount of solute. So this can't be water. It's got to be some kind of a molarity of solution that we don't know. So does that make sense? What if you had this line? What if you had a line like this? This is bag.
Wait, does it curve?
This is bag G dog.
Yeah,
What would that mean?
It was hypertonic and then it reached. Yeah, it like reached kind of.
Good. So it started off hypertonic, but it reached isotonic. Good. So it gained weight. It was definitely not as hypertonic as A. So it gained some weight, but it was able to gain enough that at this point, water's going in both directions at the same. Is it possible to get a line that does this? No. Should that happen?
No.
No, that really should not happen in normal conditions.
You did something wrong.
Yeah, you made a mistake somewhere. Because it's not going to go from hyper to hypo. It's not like you're driving and you miss the exit, you have to turn around. It doesn't do that. It gets to even and then everything's going both directions at the same rate.
Like that, like it like dips up a little bit, like not a lot, but like dips up a little bit and then dips back down.
I mean, I suppose you could see like a little oscillation kind of thing, but you're definitely not going to see it loses, oh wait, it went too far, and then it's going to suddenly go back and gain. All right. People have had trouble with this question all day. Which way will glucose travel if the membrane is permeable to the glucose?
It's gonna go that way.
Oh, it's gonna be to the one. Yeah.
A is saying it's going to go towards the right, and B is saying it's going to go towards the left. Which way is glucose going to go?
Left. A.
A.
Yeah.
I hear A.
A.
All people with A, raise your hand.
Well, doesn't it go to the most negative?
Yes.
The correct answer is A, but all day long people are picking B. Let me tell you why. Because they weren't paying attention to what the question's asking.
Exactly.
If you go by memorization, you memorized, water always goes towards the hypertonic side, so everything's going to go towards A, or side to the left. But the thing is, I'm not asking you about water. I'm asking you what the glucose is going to do. And glucose is going to go from where there's more to where there's less. That's the definition of diffusion. Anything that can pass through the membrane, and this is the bottom line, will go from where there's more of that thing to where there's less of that thing, including water. And if there's more solute, there's less water. That's why water always goes towards the hypertonic side. So be very careful. You guys actually were the one class that it seemed like most people understood what to do with this question. I know, you guys are awesome.
And it's proven to
All right.
everyone else is going to watch.
I know, it's on everybody on the video. Notice period A. We'll see what their test grades look like. All right. How about this one? What is the solution on the left at the beginning? Hyper, hypo, or iso?
Hyper.
Hyper.
It's hyper, yes.
Yeah.
Good. Don't feel too special though. Most people got that one.
Well.
All right, last one that I'm going to record. This is the most difficult question.
On the quiz test, whatever.
I would say this is probably the most difficult to think about and answer on a test if I was to put a question like this. So you've got a membrane. It's really important to read what they're telling you. So it's permeable to glucose and it's permeable to water, but it's not permeable to sucrose. So the question is, which of these choices best describes what's going to happen in this experiment? One of those choices you can eliminate right away.
The one that you can move is the sucrose moving.
Which one can you eliminate right away?
B.
B. Why? What's wrong with B?
Sucrose.
Sucrose can't pass through the membrane. So use a test-taking strategy. Eliminate that one. That one makes no sense. I also told you that anything that can move is going to go from where there's more to where there's less. So what other choice does that automatically eliminate? That eliminates D. Because glucose is definitely going to go to the right. So that eliminates D. Most people were able to get it down to A and C, and that's where the problem came in. People were not sure how to deal with the water in this type of problem. It's not E. We'll just go with that. So,
It's C.
so I hear C's and I hear a couple of A's.
Wait, don't tell us yet.
Hold on.
I'll let you think it over. I'm going to pause this while you think it over. Tell you why. So here's how you analyze this. There's a couple ways to look at this. First of all, we already said glucose is going to go to the right. Now, at the beginning of this experiment, what is A compared to B? Hyper, hypo, or iso?
It's hypertonic.
Actually, at the beginning of this experiment, technically it's iso because there's 4 on this side and 4 on this side. So it doesn't matter what the solutes are. But because the glucose can pass, we just said glucose is going to go to the right. And glucose is going to be able to keep going until the glucose itself is even. But what's going to happen is, once the glucose is even, we're still going to have more sucrose on the right than the left. So the entire molarity of this side is going to go up. And the entire molarity of this side is going to go down, which means now this would be hypertonic. So water would also go to the right. So the water level on the right side would go up, and the correct answer is A. Now, honestly, this is a difficult problem, but there are several questions I could ask you about this that would be easy. Like, which way will just the glucose go? To the right. What is the right side compared to the left at the beginning of the experiment in general? Isotonic. What is the left side compared to the right side just for sucrose?
The left side compared.
The left side for sucrose is hypotonic. You know, so there are questions that could be asked about this that wouldn't be difficult. What's difficult is the water, and I know that. And the test won't be 10 questions about pictures like this, so don't worry.
3-day rock.
All right. Very funny. All right, actually I have one more that we'll go over on the recording. This one. Which of these is the best definition of an isotonic solution? Same amount of solute on each side, same concentration of water on each side, no movement of water, no movement of solute, or all of those.
No.
I hear an E, I hear an A. I hear another A. I'll tell you straight up, there's a problem with C and D. What's the problem with C and D? Right, you would never say there's no movement of water. And we don't know if the solute can pass or not. So we wouldn't say that either, which basically that eliminates E. So is there the same concentration of each type of solute, or is there the same concentration of water?
B.
It's B. Here's the problem. It does depend on the solute, but it's the wording here. If this said there is the same total amount of solute, then that would be true. But this says there's the same amount of each type of solute. For example, remember our fish in the salt water. The reason why our fish in salt water doesn't lose all its water is because it maintains a high concentration of urea, which you don't have to know that it's urea, but it does. So if outside we have 10% salt and inside we have 10% urea, and neither one of these tend to pass through the cell membrane, this is an isotonic solution. The solutes are not the same, and that's what is messing up this question. It doesn't have to be the same solute, it has to be the same amount of solute. In fact, going back to this one, we don't have the same amount of each type of solute on both sides, but yet this is isotonic. Because it's the same total amount of solute and the same total amount of water. Okay? Alright, so now I'm going to stop. Did you want to say period A rocks again?
No, I'm okay.
You lost it. It's
Love
not.
you, though. Hey, period
Thanks.
rocks.